Welcome to the Power of ERDC podcast. I am your host, Tim Reeves with the U.S. Army Engineer Research and Development Center. Natural and man-made disasters come in all shapes and sizes, impacting communities large and small, most of the time disrupting power and critical utilities, making rescue and recovery efforts more difficult. Making the response to such emergencies even more challenging is that transporting fuel for power-generating technologies is a difficult logistical operation. Created to address many of these challenges, the H2Rescue vehicle, a 33,000-pound power plant on wheels, which, by the way, is very tough to say, by the way, was thought up, designed, and tested and validated in just a few short years, becoming a world-class example of what power-providing emergency systems, this one powered by hydrogen, can deliver. The vehicle also showcases how successful partnerships between federal, military, and industrial partners can be in quickly developing and delivering technologies that serve our nation. Joining us today is Nick Josephic, an industrial engineer at ERDC's Construction Engineering Research Laboratory, who was among the leads in developing the H2Rescue vehicle, which has not only earned recognition throughout the federal government and military, but also earned prestige by the Guinness Book of World Records. But we'll get to that later. Nick, welcome.
Yeah, thanks for having me on. This is a great opportunity to talk about the collaboration and the research that our lab was able to lead and showcase a great new technology for the nation.
I was talking about how difficult in that reading was about saying a 33,000-pound power plant on wheels. There's a lot of P's there. But this is I know we're going to get you to describe the vehicle in a second, but this is not a small vehicle, which will lead us to the end on the Guinness Book of World Records. I've seen it and heard it. This thing is massive.
Yeah, it's a Class 7 medium truck, big box truck that you'd see barreling down the road, and we converted it over to run completely on hydrogen, to add this capability to it.
Well, let's talk about that. So tell us about the vehicle and some of its capabilities and the kind of the genesis or the back of a napkin story for how this became a reality.
Yeah, so I'm the fuel cell team lead for Army Corps of Engineers, ERDC CERL, and I lead an interagency group of federal agencies. So that include, the Department of Energy, Navy, some DevCom labs. And we're always looking for fuel cell and hydrogen research projects that can strengthen our nation. Back in 2019, there were a number of natural disasters that were happening across this country. There were some wildfires out in California. We had some storms and hurricanes, tornadoes that were really affecting our communities. So when these natural disasters happen, many times, electricity, water is knocked out, and we have a lot of our citizens that are without power or water. With that emergency response, those are two of the main things that you have to do to get back in there, get power going, to start being able to rebuild those communities. So this interagency research group started brainstorming the idea of how do we build a vehicle that could support those, that emergency rebuild during those natural disasters. And since we're all hydrogen and fuel cell people, of course, we want to incorporate that into it. But by designing the H2Rescue, we can have a vehicle that can pull into a situation and immediately begin providing power. The fuel cell provides water. We can bring our supplies in the back of the truck. The box truck is air conditioned and heated, so you can turn that into your command center. And we wanted to build this multi-tool that could be used during that emergency to really help the emergency response.
You talked about some of the capabilities, and I forget the number, the amount of power it can provide. I think it was 72 hours. So what's the capability in power production that this vehicle can produce?
Yeah. So the H2Rescue, everything it does is powered by the hydrogen that we have stored on it. So we stored a lot of hydrogen. So we stored 176 kilograms worth of hydrogen on there, which is a lot. And that hydrogen, we're using it to power, the driving aspect of it, but also the power export. So we can power export up to 25 kilowatts at a time for up to 72 hours continuously. And that's about powering 15 to 20 homes for 3 days straight.
Oh, wow.
Now, yeah, so we can export a lot of power. Now, we can also export a lot less power than that. We can, if you're just plugging in equipment and tools and things like that, we could have that vehicle sitting there at that emergency sites for days or weeks or even months if you're just powering, your computers and safety equipment and things like that. But we literally could power multiple homes with the amount of power that this vehicle can produce.
That's amazing. So as we have seen these disasters, you mentioned 2019 being a tremendously difficult year when it came to disasters. Where does a capability like this vehicle kind of and this technology kind of fit into what could potentially be a great an emergency response
Yeah.
effort?
So we are really lucky because Department of Homeland Security was part of our team members, and and FEMA is associated. So what typically happens during an emergency is diesel trucks will pull into an emergency situation, bringing your crew or your equipment, and they'll tow in generators, usually diesel generators, and then other trucks will tow in fueling tanks. So with this vehicle, what it allows us to do is we don't have to tow in that extra generator, power generator. We don't have to bring in people who are experts in setting up generators or maintaining generators. The vehicle itself, the H2Rescue, is both the vehicle that we can drive therein, bring our supplies in, and it becomes your power generator itself. So we can eliminate having to bring in extra generators to set up for that situation. So it's a logistical reduction. Now, the other interesting thing is with fuel cells, they're typically twice as efficient as a combustion generator. So we're having to supply less fuel when we're in this emergency situation. So we can either extend our duration or have to bring in less fuel or bring in fuel less frequently than when you're doing a combustion engine. So it gives us a lot of flexibility.
And a lot less logistical chaos, I guess, in and around a disaster that's already chaotic enough. You're minimizing
Yep.
your footprint. Yeah. So I guess one of the questions I had early on is, and you mentioned, you're hydrogen people, so you were going to put hydrogen in this, but why hydrogen? Why was this particular type of fuel selected for this particular type of mission?
Yeah. So fuel cells are an electrochemical reaction. So you don't burn the fuel. So we're not having to burn that fuel, but like I said, it's twice as efficient as your combustion generators, so we can increase that duration. And hydrogen is available in all 50 states. Our compressed gas suppliers all have supplies of hydrogen. It might not be seen or known everywhere, but we do have hydrogen in all 50 states via our compressed gas suppliers. So it's out there. So it's showing another tool in the toolkit that we have these alternate fuels other than the traditional, diesel, gasoline, things like that. Because we want to have the most flexibility in our fuel sources and in our technologies that makes our country stronger when you have multiple choices of what fuels you're going to use. So we see hydrogen as one of the tools in the toolkits that can be used to meet the mission.
You were talking about we talked about it earlier as well, not just as it's producing power, but producing water as well, potentially producing water,
Yep.
so because of the use of hydrogen. How does that work in this design
Yep.
and potential? How does that fit into this?
Yeah. Another great benefit is when we feed the hydrogen into the fuel cell, the electrochemical reaction is combining oxygen from the air with the hydrogen that we brought stored in the tanks. So that reaction creates water, chemically pure water. So as we're producing power, we're also creating water that could be used in that emergency. So excuse me. So it could be used for washing equipment, whatever's needed at that time. So another added benefit, while we're producing power, we're also producing water. And with the amount of fuel that we have on the H2Rescue, we're producing about 400 gallons of water during that time. So that might be needed in an emergency.
And you said, I think when we were talking earlier, you said this, it's not potable water yet. That design, it's not drinking water per se, but it's things for washing equipment or some other
Yep.
things that would free up other resources for those other emergencies or other uses.
Correct. Yes. Right now, it is chemically pure water, and we would not want to drink that. That would mess with our electrolyte balances in our system. But one of our great researchers here is working on remineralization of that water. So it's just an extra step to take it back to potable. But in this version 1.0, we took this from a paper concept to a fully working model and showing that this technology can work and really be a benefit to our nation. And like you said, we're creating pure water, so great for washing things. And it's just one more step for remineralization, and we have a number of researchers working on that.
So we talked about partnerships earlier. You mentioned some of them, but let me just, this is a pretty good team. If you were putting together a starting lineup, I would think this would be the people you'd want to have. At the federal level, you had the Department of Energy, the Department of Homeland Security, and the Federal Emergency Management Agency, or FEMA, that you mentioned earlier. Within the military, we had our teammates involved from U.S. Army Ground Vehicles Systems, part of DEVCOM, and the U.S. Naval Research Laboratory. And I think we would all agree none of this would be possible. I know this is a contract partner, an industrial partner of ours, Cummins, who I'd imagine played a major role as we, in constructing and producing the vehicle. So at ERDC, and particularly the team at Searle, has a rich history of researching and developing unique energy options for civilian and military applications. What was ERDC's piece of this elaborate puzzle?
Right. So we were the technical lead on this, and so we helped design the overall specs of the vehicle and the capabilities that we wanted. We designed the testing that we wanted to test this vehicle, and we'll get into that later, of all the rigorous tests that we put it through, and the design plan for that. And then we were able to we did put out a bid, our request for proposals out on the street, and we had multiple companies propose to that. So we technically reviewed all of those, and Cummins was selected as the best fit for this program. So you're right; they were our technical partner on this, and they were able to do the actual construction of the vehicle. We did we at Searle did the design reviews, we did the specifications on what they had to meet, and then participated in all the testing of the vehicle.
We'll talk about those tests. I can't imagine it for something that would need to respond in the case of an emergency, whether that's a wildfire in California or in the West, or hurricanes in Florida. You can't just drive this down the street and assume that it's fit to go. So talk about the testing.
Yeah. It was great. So we did multiple tests, starting from, system tests at the Cummins manufacturing plant. And then we moved on to a number of different field tests. So we did a dynamometer testing on it. So that's putting the vehicle basically on like a treadmill and running it through its paces, like it's going up and down the mountains, starting and stopping, and doing all sorts of different techniques on a dynamometer testing. Then we moved it into the road testing. So we started driving it around just on your normal city streets, and we did both highway and local driving, stop and go driving. And what we wanted to do was we filled up the tank, and then we put it through these paces. So we wanted the vehicle to drive 180 miles in each of these tests on mixed roads, like I said, in the locals and then on the highways. And then we wanted to export power for 72 hours straight. So our first test, we did that around the Sacramento area. Did great. Driving all over, met all of its marks, and we got a lot of good data on its fuel consumption, its power output, water production, all sorts of great data. I'm a researcher, so I love getting data numbers.
Right.
So in that test, up and down some hills, it was in, 100-degree heat. It was a warm day out there. Lots of good data. Second step, we sent it out to the Denver area, to the Golden Denver area, and we did it in high altitude testing. Same thing. We wanted to do a 180-mile drive test and then do the power export. So some of the cool stuff that we found out there is, again, there it was freezing when we did it. So we were operating in cold weather. We were operating at high altitudes. So when you go up in the altitude, there's a lot less oxygen in the air there. So we did find that at the highest level that we were at, we did actually find a spot where from a cold start, there wasn't enough oxygen in the air for us to start that fuel cell up and start producing. And we literally had to take a filter off of the air intake, and that gave it just enough airflow to be able to start it from a cold start. Once the fuel cell was warmed up, no problem. But we did in each morning when it was in these cold, high temperature or high altitude, we did from a cold start. We had to just pop that filter off. It was constricting it just enough, and there wasn't quite enough oxygen in the air. So that was one of the fun anecdotal things that we find in testing. The other thing. Oh, go ahead.
No, I was gonna say that's I'd imagine for you. You said data a minute ago, and that's one of the things you like. I would imagine
Yep.
that one of the things you like too is like, oh, we broke it, well, how we break it, or type thing, and
Yep.
figure, which is I guess the whole fundamental parts of R&D.
Oh yeah. R&D is how can we push it to the limits, and what do we have to do to solve that for the next one? So in the mountains, we with that high altitude and that low oxygen, we figured out we needed to do some little bit more larger in air intake on that manifold, and then we know we could go that high. The other thing that we did was during that 72-hour test, again, an example of R&D that you can't prepare for everything. We started our testing, and who knew that tornadoes can affect the Denver area? We're testing an emergency vehicle exporting power, and while we're exporting it, we're about 20 hours into the 72-hour test. Tornado sirens start going off and tornado warnings all over the Denver area. We have to shut the test down for safety, human safety factors. We don't want to do a test that would endanger any of the researchers. But and all the days, how do you prepare for tornadoes coming through Denver to shut down our 72-hour test?
Yeah,
Just the fun of research.
yeah. Good thing you weren't on the coast. When you find yourself in a hurricane warning all of a sudden.
Yes.
Yeah. So
Yep.
all right. So let's talk about the fun part. Yeah, you and your team are now part of a Guinness Book of World Records for the longest distance traveled, and I'm gonna get this right, by a hydrogen fuel cell electric heavy-duty vehicle without refueling.
Yes.
Over a three-day period in October of 2024, the truck traveled more than 1,800 miles, 1,806 to be exact, on one tank of hydrogen fuel. How did this become an idea, an objective, and what did it take to pull this off?
Yeah, great question. So after we did those 180-mile tests, the power export tests, we really wanted to do a long duration test. Again, as I mentioned earlier in the podcast, the fuel that drives the vehicle can also be used for power export. So we said we want to do a long duration test. What if these vehicles had to be deployed from their home station across the United States? How far could we get to support an emergency? So we set up a program to do a long duration test, and this was not on a closed track. Again, we wanted to do it in real world conditions. So we completely filled up the tanks of hydrogen, that 176 kilograms of hydrogen. And it was very fun. The Guinness book did come out because we thought with our calculations, we based on the amount of fuel we had, we knew we could beat the record. So we had Guinness come out. They sealed the tanks. You have to sign. They put all this tape on it, and you have to sign it, and they take pictures of it. So you could stop for the evening, but you can't break the seal on the fueling tanks, right? So we designed some routes around the Sacramento area. Again, mixed driving, and just started doing loops, about 90-mile loops that we started doing, and just kept doing that over multiple days. And what we were able to beat is there was a you read our record, but we beat every fuel cell vehicle in the long duration because there was a Toyota Mirai, which is a sedan that had over 800 miles on a single tank. There was a hypermiler car, so a very aerodynamic vehicle, and that one had, I think, about 1,300 miles. And then there was even a locomotive that had over 1,500 miles on a single tank. But we were able to beat all of those just in the driving around the Sacramento area on these 90-mile loops.
Okay.
And
That's
yeah,
you're doing a 90-mile loop around Sacramento.
yeah,
In this, let's just say the opposite of an aerodynamic vehicle. It's
yes.
not a small. So at some point, somebody who's like out in their front yard doing gardening sees this truck coming by over several days. You've got to be getting some looks, or it's got to be among the most boring drives of all time.
Oh yeah,
Yeah,
both.
yeah.
People thought they were in the Matrix. Like, didn't I see that truck pass by me again? And the funny thing was we had two people in the truck at all times. We had, a professional, a driver, because you have to have certain, with this large of a truck, you have to have certain certifications to drive it. And then we had an engineer sitting beside them, with the computer monitoring the system and all that stuff. And originally we thought we would rotate the driver out, but after I think the second day, the driver's like, nope, I'm going to do the entire thing. He didn't want to give up his seat. So we had one driver. Again, it was spread out over multiple days, but he's an amazing driver and he did not want to give up his seat. And so he did the entire 1,800 miles to build that record. So he was definitely, a workhorse to make it through that.
So did you ever have a vision at some point during your career or education and that kind of stuff that I'm gonna be part of a Guinness Book of World Record, holder?
Never thought it, but it's the beauty of ERDC research is if we can dream it up, we have the opportunity to do this research. And it's what makes ERDC so strong in its research. But no, I had no idea I'd ever be a part of something like that, but it definitely feels good.
There's questions after the fact, after the podcast, of like what soundtrack was playing, who had control of the
Oh,
radio, that kind of stuff.
yes, yes.
So yeah. So I guess my final couple of questions deals with what's next. You mentioned earlier this was version 1.0. This was proof of concept in a lot of ways, and I'd imagine even on the 1,800 miles, there were lessons learned and things that broke or things challenged. Where do you take this thing next?
Yeah, we've got a lot of exciting areas that we want to take it. So one I mentioned, we've got researchers working on remineralizing the water so it's potable. That just makes the entire project even stronger. If you can say we can drive into a situation and give you potable water and power and warmth and cooling and we'll bring supplies to you. So that's one that we're working on. And then another step is right now we can power all sorts of pieces of equipment. We've got many outlets on there, both 110 and 240. So you can plug, regular equipment in and even higher power equipment. But what we want to do is we want to be able to meet the tactical microgrid standards and these other interconnection standards so that we could come in and connect to any microgrid or any building that and power that safely and sufficiently during that emergency. So that's really a next step is meeting those microgrid, being able to power those microgrids. And then again, there's always things that you want to improve in the second version. Like we talked about the air filtration on that. There was oh my gosh, the whole team is drooling about like the fuel cell that we have now is twice as powerful and in the same footprint. The power density has increased in the fuel cell that Cummins has made over the duration of our project. This has jump started that fuel cell research. So we have a much higher power density fuel cell. We could also optimize the fuel storage on there, and we could put a lot more fuel on there because we used commercial off the shelf tanks, and we didn't build any specific tanks. So there is lots and lots of research, and we'd love to build a fleet of these and then get them in the hands of the first responders to be using those in limited capability or limited capacities as part of a demonstration. And we've had a lot of good interest in people who said we could use this kind of technology. Well, we were able to go to the World Fire Congress and we met with a bunch of leaders in the, firefighting world. And they saw the capability of having, these fuel cell powered vehicles that can also generate water. And saw some real capabilities there. We know that, FEMA and DHS has opportunities for trucks like this. So we really want to make a fleet of these and get them into the hands of the first responders to use as a demonstration.
I know you've had a very successful career and such, but I wonder what it's like to go the emotional connection, right? When you have something on the back of a napkin, you say, "This could work. This might work. One day, this will be cool to for it to work." To seeing it not only work, set a Guinness Book of World record, but also have the capability to save lives, provide needed material, capabilities and such. That's got to be like a cool feeling, I'd imagine.
100%. It is the most fulfilling part to know that you're part of this research organization, that we can take concepts and get them out into the field and into the hands of people and really help our country, be stronger, have more energy security, help our nation's population during an emergency. It's such a fulfilling part of our jobs with the ERDC to do that. I can't express the feelings that you have of seeing your research move from a sketch, like we're literally sketching on pieces of paper and
Sure.
saying, "I think we can do this," and then a few years later, having it out there and seeing it drive is just an amazing feeling.
Well, listen, Nick, thank you so much for the time today. Thank you for your work and your energy behind this. No pun intended. I wish I had thought about this earlier. That'd be a really good joke to have had scripted. I'll think about that
Yeah,
next
you
time.
should have.
But the energy you put behind it, I really appreciate and enjoy seeing in the conversation. So we'll catch up, I'm sure, later. So um, to those viewing us and listening to us, thank you for joining us for the Power of ERDC podcast. We will see you again next week.